Welcome to Real GMAT Problems, episode 35. Doing real GMAT problems is one of the best ways to make test day go well, so let's work through a few examples together. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through today. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be quite similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to learn from each one. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go or you're working out, but just do your best. It's a great mental workout, even if you can't get all the way to the solution the way you could if you were writing it out in a more controlled environment. If you are in a situation, though, where you can physically write down what you would on test day, that's definitely ideal. Let's start with a warm-up question, and then we'll explore some more complex questions that build on a few central concepts. This is problem number 146. The problem says, if 0 is less than or equal to x, which is less than or equal to 4, and y is less than 12, which of the following cannot be the value of x times y? I'll read that again. So they say if x is between 0 and 4, but it could be equal to 0 or 4. So the way that's expressed is 0 less than or equal sign x less than or equal sign 4. So you've got if x could be 0 or 4 or anything in between, and y is less than 12, which of the following cannot be the value of x times y? Option A is -2. Option B is 0. Option C is 6. Option D is 24. And option E is 48. I recommend pausing here and doing your best to solve the problem, and then we'll pick up in a moment. Great warm-up problem for a few reasons. First, it's not terrible in terms of the math and computation involved, and it builds on many of the central themes that we've discussed in the series so far about organization and using answer options to your advantage. First things first, it's worth noting that these kinds of questions can throw folks off since it's a little bit hard or maybe even impossible to quote unquote set up an equation and quote unquote solve the problem. Instead, you're basically forced to use the answer choices in your analysis. It's not a huge shock to the system for most people, but it can be a little bit strange. So it's a good idea to get some exposure to these types of questions, just so the format itself isn't a surprise on test day. In terms of approach, most of us will just test each answer one at a time. There are certainly other ways to approach the question, but I think those approaches are probably niche enough to just pass over for now. If you've been following our content for a while, you won't be surprised that I recommend a clear system of organization. But I guess just going back to the previous point and making that clear, like I think testing each answer one at a time, I'm just going to focus on that because the other options, like if you're using some of the other options, you're probably not struggling with the question at all. And you might want to test the answers on a different type of question. And so I think even if you did this one a different way, that'll be the maximum benefit that we can all get from talking through this one. So that's my logic there. So like I said, you won't be surprised I recommend a clear system of organization. Here, some simple columns can work. One for the value of x and one for the value of y. And then I'd probably make another one for the value of x times y, which of course is what we're being asked about. So really just writing what's given and asked and tracking some of the answers that we're going to plug in. You also won't be surprised probably to hear me recommend writing what's given from the problem in general. So I would for sure note that x has to be between 0 and +4 on my page, but that it could be equal to both. So 0 less than or equal to x less than or equal to 4, as well as y is less than 12. I would have that noted for sure. And yeah, it might not be a game changer for you on this particular problem to write things out well, but on slightly more complex problems, which we'll look at in a moment, it can definitely be the difference between being right and wrong. So, highly recommend building good habits and executing on those habits, whether you feel like you need to on any particular problem or not. It's that execution 100% of the time that's really going to get you the goal score that you want to see. Obviously, there's other things involved in it, like having the right knowledge and practicing enough. But most of you are going to have the right knowledge and practice enough. But most of us struggle heavily once we have the right knowledge with getting credit for that. And you've heard me talk about that a lot in this series. So trying to set you up for success there. Let's start with option A, which is -2. That represents the potential value of x times y. So let's see if we can find some numbers in the given ranges for x and y that we can multiply to create -2. I can think of a couple, but what probably comes to mind first is just making x 1 and then making y -2 itself. And just to bring in to my world there, my thought process is that x cannot be negative. It can only be 0 or positive. So if we're going to get a negative result, it means that y has to be the negative value. And that's what's going to make the product negative. That's fine though, because y can be any number that's less than 12. So as long as I'm clear on that, I'm likely to figure out that a is possible. Now the question is asking which is not a possible value of x times y. So let's go ahead and eliminate option A. And just to be clear about what I'd be writing down, I would write 1 under x in that system of columns I had. I'd write -2 under y, and then under x times y, I would write -2, just to make sure I'm not making a mistake. And let's just move on to option B. Let's test that one. So option B is 0. Generally, if I want to make a product, which is something multiplied by something else, if you need help with some of the terminology and some of the math basics I'm working through here, if you're just starting out, we've got a whole math basic series linked for you below that'll bring you up to speed on this stuff that you probably knew really well at some point, but might have been a little while. It certainly was for me when I was starting to study back in the day. So if I want to make a product equal to 0, I just need one of the terms to be 0 because anything times 0 is 0. And either x or y can be equal to 0 here. That's in the allowable range for both values. So I'd probably just make them both 0 and then just write 0 under x, 0 under y, and then 0 under x times y. And since 0 is a possible product there, I'll go ahead and eliminate option B. Let's look at C, which is 6. Plenty of ways to get x times y to equal 6. I might just make x equal to 3, y equal to 2, since both of those are allowed, but obviously the reverse is also possible and many other iterations there. So that means I can eliminate C. And then looking at D, which is 24, we could do a bunch of different things, but I'd probably just make x3 and y8, something like that. And at that point, I would be confident that the answer is E. But just for the sake of completion, let's talk through it. We're going to have trouble coming up with the right values because the maximum value that x can be is 4. So you might recall that option E is 48. And in order to get the product to be 48, if the maximum value of x is 4, we would need y to be 12. And then 12 times 4 would give us 48. But since the problem tells you that y has to be less than 12, it doesn't have the less than or equal to sign that x has, then it's actually not possible to get x times y to equal 48. So E, as in echo, is our answer. Interestingly, it looks like about 10% of us go for A. And I was a little surprised by that at first, but the more I thought about it, the more I think folks might just not be considering that y can be negative. And that kind of makes sense. I think there's just a little bit of psychological anchoring going on there, if you're familiar with that term. It's kind of like priming, like if someone talks to you about a delicious meal, you're like way more likely an hour later to come up with the idea to try to have a delicious meal that that night. That's called priming or anchoring. Yeah, it's a whole other conversation. I'll just gloss over that. But I think we kind of get psychologically anchored with the whole X has to be larger than zero first, and then maybe just subconsciously that influences us to not think that y could be less than zero. That would be my guess. I don't know for sure, but it seems somewhat reasonable. So just be on the lookout for that kind of thing. It's part of the reason I recommend writing what's given and asked 100% of the time because it can just help reinforce the real constraints of the problem. Oftentimes, when we start working through the math and details of a question, we can kind of lose track of the specific constraints. Things can get a little fuzzy. And that's why it's really, really easy to pick options like A, even though upon review, we look back and we're often surprised, like, how did I mess that up? How did I even forget that? It seems so obvious in retrospect. If you find yourself saying that to yourself a lot, which is really common, then writing what's given and asked is a great step in the right direction there. But again, you want to remember to do it 100% of the time. It's that consistent 100% execution that really makes the big difference. It's executing when you don't feel like you need to. Those are often the problems where we need it the most, unfortunately. Obviously, all of our lives would be a lot easier if we could just kind of go through this thing willy-nilly. But not usually effective in my experience. Maybe a few of you can do it like that, but that definitely wasn't me. I had to be on point. I had to take myself to places I didn't even know I could go, to be truly honest. But it was good for me. It was good for me. It helped me level up, you know. So hope the same for you. Right? If we're going to go through these difficult things, hope that it makes us better. So keeping things written out clearly on your page as you strategize for and solve questions, it might seem kind of redundant, but I think you'll find that it has a surprising amount of value. So that's probably enough to protect you from falling into the slight trap there of picking A. And hopefully you're warmed up now. So let's explore some problems that have similar themes, but might be just a little bit more complicated. Quickly, if you feel like there's a note to self that might be valuable to make there, you can text or email that to yourself, something you want to remember from that problem if you're on the go. Or obviously, if you're in a more controlled environment, I recommend adding that to any note-taking system, any place that you're tracking things you want to remember in the future. If there is that note, I recommend pausing. I'm just going to jump right into the next question. This is problem number 161. The problem says the positive integer n, the letter n, as in night or nobody. The positive integer n is divisible by 25. If the square root of n is greater than 25, which of the following could be the value of n divided by 25? I'll read that again. The positive integer n is divisible by 25. If the square root of n is greater than 25, which of the following could be the value of n divided by 25? Option A is 22. Option B is 23. Option C is 24. Option D is 25. And option E is 26. Again, recommend pausing, working on the question on your own, and getting as far as you can. Great follow-up to the previous question for a few reasons, but it can function as a nicely more complicated example of the same exact approach to solving, which is essentially just guessing and testing with the answer choices. So I liked this as a follow-up to the previous one, and I think it'll drive some of those points home, hopefully well. It's also a great example of how just writing what's given and asked well consistently can help you avoid major pitfalls, just piggybacking on that concept to begin. For example, in this question, 17% of us are choosing the exact same incorrect answer. So it seems like there's a lot of gravity with the trap answer on this one, almost twice as strong as the previous one. So let's start with the correct solution path, and then I'll backtrack to what I mean about pitfalls. If we write what's given and asked, you'll note that we're given quite a few constraints for the number n. First, it has to be positive. It also has to be an integer. Again, check out that Math Basics series if it's been a while since you thought about what an integer is. It also has to be divisible by 25. But in addition to all of that, the square root of n has to be greater than 25. So it's just a lot of stuff to keep track of, and all of it ends up being really, really important for getting the right answer here. Further, we're not just asked to solve for n, we're asked to solve for a number that could be the value of n over 25, n divided by 25. So that's just much more complex than the previous question. I think most of us would agree, and it's a lot to hold in your head. I'm sure a few of you out there are capable of all of that, and if you're getting great results by holding everything in your head, then by all means, keep doing what you're doing. But if you're not seeing the results you want to see, I'd recommend just not doing that. Write it all out. For myself, for sure, trying to hold all that in my head tends to be a losing proposition, especially as I'm in hour 2, 3 of the exam. That gets really gets a lot tougher. A good example of what I was mentioning in the previous question. It's a good habit to have built when things get more complicated. I thought this was a good example of that. So more on that in a moment. Just like the previous question, there are a few different solution paths that can make sense, but I'm just going to explore the guessing and testing with the answers thing a little bit more just to emphasize a few of the points we made previously. And I hope and think you'll find that helpful. So we start with writing everything given an S, and then we just go down our list of answer choices. Option A says n over 25 is equal to 22. So remember, all the answer options are values of n divided by 25. So what I'd probably do there is set up an equation that just says that. You can see from, so the equation would be n divided by 25 equals 22. And then from there, I can multiply both sides of the equation by 25 to get rid of the denominator. And that would get me n equals 22 times 25. And it's probably worth mentioning that just a good rule of thumb to save any big computation on the GMAT till as late in the problem as possible. Because a lot of times looking at the number, like, I don't know what the right way to say this is, like uncomputed or just like in its factored form. So n is 22 times 25. It's often easier to reason through the problem when it's just in pieces like that. Even though a lot of us have the reflex from school to just be like, oh, 22 times 25, let me bust out some long multiplication. Now, long multiplication definitely has its place on the GMAT. Don't get me wrong. Big fan of it when the time's right, but perhaps obviously you don't want to do it more than is absolutely necessary because it's quite time intensive. So again, just quick tip. I recommend leaving computation and problems till as late in the problem as possible. I've probably given that tip in other real GMAT problem series, but just in case I haven't, I think you'll find it quite valuable because a lot of times later in the problem, stuff's going to cancel out. This isn't the most amazing example of that, but it's an okay example of it. So let's think about n equals 22 times 25 for a second with option A. That's great. N is definitely positive. It's definitely an integer, and it's definitely divisible by 25. If I divide 22 times 25 by 25, I get an integer result. That's the definition of divisible. And again, if you'd like more background math around divisibility and how we reason through all that stuff, that's all linked for you below in that Math Basics series. And I needed a major overhaul and refresh when I was starting out, just to be super clear, you're not alone in that. So please, if needed, just go brush up on your basics and come right back and we'll be waiting for you. But we've also got another constraint here. So even though 22 times 25 passes the first, 4 constraints, the final constraint, which is that square root of n has to be larger than 25, does not work. So let's think through that for a second. Let's treat that as an equation. Square root of n equals 25. Let's square both sides. And that might make it easier to see that n would equal 25 times 25. Again, leave it in the not multiplied out form there. So it's the question tells us that square root of n is greater than 25. So even if square root of n is equal to 25, which is 25 times 25, that's already larger than 22 times 25. 22 times 25 is definitely not bigger than 25 times 25, and n can't even be 25 times 25. It's got to be bigger than that. And so that is the major unlock on this question because now we can eliminate option A, but we can also eliminate a lot more answers. For example, if you visualize B the same way, that's saying n over 25 is equal to 23. If we multiply both sides by 25 again, we get n equals 23 times 25. But that is for sure not bigger than 25 times 25. And then we can just go down the list like that. We can eliminate C and we can eliminate D for the same reason. That leaves us again, interestingly, with option E, which is the correct answer, which is 26 times 25, which is the only one of those options that's bigger than 25 times 25. So Is that the most complicated, most difficult GMAT question you're ever going to do? Almost certainly not. But is there some interesting stuff that you can learn from it and leverage on test A and more difficult questions? Yes. It's a really good example of how taking your time to set up the problem and making sure that your workspace is mapped out well and that you set the question up and you organize your information well can really pay off with a faster and lower risk path to the correct answer, rather than what a lot of us are tempted to do, which is rush through the setup, try to kind of panic our way to just doing math. Like, oh, I need to get to the doing math part. That was me back in the day. I think I just subconsciously associated making progress on a GMAT quant question with doing actual computation. And that hurt me. That hurt me. It would have been much better if I had just known from the beginning that it's a good idea to take my time to set things up, and that makes me faster in the long run. It's kind of like going to a business meeting without an agenda. I don't know if any of you have ever been to those, but they're not my favorite. And you can probably imagine why. But the idea is like, how long would it have taken someone to make an agenda for the meeting? I mean, in a lot of situations, it's like 30 seconds, maybe 5 minutes, maybe for really complicated stuff, it's an hour or two. But how much more efficient is the meeting? How much better is the team morale? How much more bought in is everybody in the meeting? How much more excited are people to come to work at the beginning of the day? How much less drained are they at the end of the day? How much more energy do they have to put into the projects that they want to put into energy into to move the business forward? This is like, I'm not saying it's a silver bullet here, but it's just a good analogy for not rushing into things with your math questions and just doing a little bit of setup and diligence on the front end. So again, good example of that. And it might not always feel natural. I think it's really important to embrace that. Like under time pressure, that's like the most unnatural thing, but it really pays off. So yeah, highly recommend that, and just trying to be as heavy-handed as I can with my recommendations here, because that's what I needed back when I was in your shoes. Is yeah, I needed someone to be like, "Hey man, when are you gonna set the problem up right?" And yeah, it took me a lot longer to get my score than I wanted it to, and hopefully I'm saving you from that fate, which is not fun, let me tell you. So, what about the trap answer I mentioned? Like I said, 17% of us are going for the same wrong answer, which is D. And you might remember that's 25. So n over 25 equals 25. I do think that makes sense in a similar way to the trap on the previous one, because if you write out n over 25 equals 25, and then you solve like I was doing, and you say n is equal to 25 times 25, it's just really tempting to forget that square root of n is greater than 25, or simply misinterpret what the question was saying and think that square root of n is equal to 25. And I think that's probably what's happening for a lot of people, is they're just reading too quickly, or they're not noting that constraint, forgetting about the constraint, or just misinterpreting. Or like I said, you start doing math and then you get to option E, and like the original constraints are a little fuzzy. They kind of get a little, they're not as crisp as they were at the beginning of the problem, and that's why it's so helpful to have them written down. Even having them written down, again, is not necessarily a guarantee you're going to get the question right, but it greatly reduces the risk and it greatly increases the odds of success. So my guess is that's what's happening, and why a lot of us are going for D. And that's very fixable. So similar advice to the previous question. I guess many of the previous questions I've talked through here with you today. Sorry, over the many episodes of this that we've done, 34 so far, 35 now. But I know for myself, like I was saying before, it's just good to be reminded of important things over and over and over again. Like for the really important stuff, I don't know if I could even be reminded too much. So hopefully you find it helpful. Let's shift gears a bit, and let's try a problem that's related but doesn't necessarily implement the exact same guess and test approach. And hopefully I've made my points quite well there. So again, if there's a note to self for you on that question, I recommend pausing and making that note to self right now. Okay, last problem. Problem says, in the formula, V is equal to 1 divided by, in parentheses, 2 times R, close parentheses, to the third power. So we've got 1 and then divided by 2 times r in parentheses to the third power. So that to the third power is in the denominator. It's not like cubing the whole fraction. So v equals 1 divided by, in parentheses, 2 times r raised to the third power. In that formula, if r is halved, meaning divided by 2, then v is multiplied by, and then we get some options. So let me just read that again for continuity. In the formula, v equals 1 divided by 2r to the third power. If r is halved, then v is multiplied by, option A is 64. Option B is 8. Option C is 1. Option D is 1 over 8. And option E is 1 over 64. Again, recommend pausing, getting as far on your own as you can. By the numbers, this one is a little tougher for us to grasp as a group, which I think is kind of interesting because I think on the surface it appears maybe to be a little simpler than the previous question. Yeah, but perhaps there's a good lesson here to not judge a book by its cover. It's pretty difficult to know in general how hard a GMAT question is just from looking at it. And that's why I've done my best to encourage you to have a consistent approach to every problem. Like I was talking about at the top, whether it's easy, medium, or hard, just your approach doesn't change. In contrast to the previous questions, though, I don't think this is a particularly good opportunity to guess and test with the answers. It's definitely possible, but I think you're going to find it like just overly labor intensive. So instead, I think this is a good one to just use algebra or insert a fabricated number. Both are viable approaches. We'll go through both. I think the trap comes from the algebra approach, though, personally. So I think plugging in the fabricated number is probably a good way to go if you find that you make those kinds of algebra mistakes that this one seems to invite. But again, if you're having great success with algebra and you're not making these kinds of mistakes, then by all means, keep doing what you're doing. Let's start with the algebraic approach, and I'll talk about why it's a little dangerous. We can begin by computing the value of v. So 1 over, in parentheses, 2r cubed, we can just cube the bottom. 2 times r times 2 times r times 2 times r is just 8 times r cubed. So we would wind up with v equals 1 divided by 8 times r to the third. And again, Math Basics episode on exponents linked below if you're not sure how that works. Then we can cut r in half and we can compute the value of v. So the original value of v is 1 over 8 times r to the third. If we cut r in half, the original formula would be 1 over 2 times r over 2 in parentheses to the third. So 2 times r over 2, that's just r. And so we'd wind up with v equals 1 over r cubed. So the original v is 1 over 8r cubed. If we half r, we get 1 over r cubed. And a good number of us realize that if we go from 1 over 8r cubed to 1 over r cubed, then we've essentially multiplied by 8. A lot of us can figure that out. And that would get us to option B, as in beta, which is the correct answer here. And if you feel comfortable with that kind of approach and you don't find you're making errors when using it, then it's a great way to go because it's definitely fast. But as I mentioned, it can be really risky for certain types of people because apparently 15% of us are choosing D, which, as in delta, which you might recall is 1 over 8. And I think we don't have to stretch our imagination too much to realize why folks might be choosing 1 over 8 instead of 8. It's pretty easy to get mixed up when fractions are involved, especially just if you have 1 over 8r cubed and 1 over r cubed written on the page and you're just feeling the time pressure. It's easy to kind of get tricked there. So, of course, all the advice I've already given about good organized scratch work can help, but what if you're doing that and you're still missing questions like this? Or what if the algebra approach just doesn't click for you? The good news is you can experiment with plugging in a fake number like I was saying before. So we've got a whole episode deep diving on the process of plugging in numbers, and we'll link that below for you also. But the good news in this problem is that you just need to pick a number and calculate the values, which is a little simpler than the typical approach. So I'm going to just kind of gloss over a big rehash of the approach here. Let's pick a number. I like choosing things to replace R with something like 2 in this kind of situation because it's easy to cut it in half. And it's also not too big since we've got exponents to compute. If I pick something like 10 and I got to do 10 to the third, I mean, I guess it's not the end of the world, but I'd just rather deal with small numbers than larger numbers in these kinds of situations. Obviously, there's plenty of situations where I'd rather deal with larger numbers, just generally not on the GMAT. So it's worth noting that as long as you do your math correctly, you can select any number here and still arrive at the correct answer. If we plug R equals 2 in, though, then we would get V equals 1 over 2 times 2, and then 2 times 2 raised to the third power, which is, of course, 1 over 4 to the third power. And you can either memorize that or do the long multiplication to get 64. 4 to the third is 64. So we would get V equals 1 over 64 there. Then we simply cut R in half to make it 1. And then we substitute that in to see what happens to V. There, we would have V is equal to 1 over 2 times 1 to the third power, which just becomes 1 over 2 to the third, which is 1 over 8. And I think when folks are looking at 1 over 64 versus 1 over 8, it's a little less likely that they're going to pick D rather than B. That's been my experience. I could be wrong in your situation, but most of the time that's quite helpful. There's still a strong possibility, though, if you're just looking at the numbers, 1 over 64 versus 1 over 8, that you might mix them up and pick 1/8 instead of 8. That's also really, really understandable. And so I think when you've got variables changing around in situations like this, it's a good idea to make a variable for the first V and just call it like V1, and then the second V like V2. Or you could write down on your page V equals the original value and like N equals the new value of V, something like that. Just picking some representative variables to keep them separate. That kind of thing can go really, really far. So if you're like doing the good scratch work stuff and you're plugging in the numbers and you're still getting a little turned around and confused, then just think about labeling things with clear variables as you move through your math. And that should be a huge, huge help. But I have found, again, that just plugging in the numbers instead of doing the algebra helps a lot of folks too. So I would experiment with both and see what resonates. Using representative variables is something I've talked a lot about in the past and very relevant to this kind of question. So one last time, if there's anything you want to remember from those problems, I recommend making a note to self, text or email it to yourself, or make a flashcard or something that you're going to be studying on a regular basis so that you don't forget them. Like I was saying before, if you just remind yourself of these new behaviors, new concepts enough, they'll become second nature, and hopefully it won't be a struggle to get a great score on test day. If you have any questions about any of this material or you're feeling stuck with your GMAT progress, you can reach us anytime at the GMAT strategy on current social channels, or you can email us directly. Our email address is contact@thegmatstrategy.com, contact@thegmatstrategy.com. And we're always happy to hear from you. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content. And I highly recommend checking out our free presentation on how you can achieve your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.